Hello again, polar coordinates. This one threw a lot of you. And actually, I felt like I had a really good question from class. So we're going to talk about this in two parts. The first is just how to solve this. And the particular problem here was the formula for this part was x squared plus y squared is equal to 1. And the formula for this part was x squared plus y squared is equal to 16. And your region R was this shaded region below. And you were supposed to just set it up with polar coordinates and then not integrate it. So it said do not evaluate. All right. So what we had is we have this x squared plus y squared. And my formula for the exchange, which would be the following. It would be x is equal to r cosine theta, y is equal to r sine theta, and dA is r dr d theta. And you're going to pop all this in there. And how do you figure out what your R limits are and your theta limits are? Well, the R limits come from shooting an arrow from the center and looking at where it strikes in and where it strikes out. So it strikes in at R. So this is the transformation. Let's separate this on my sheet. And then limits of integration. Are going to be R goes from 1 to R equals 4. Now, some of you had put -1 to -4, and you accidentally got the actual, if you integrate all the way through, you'll get the same answer as if you had done 1 to 4. That was a complete accident. And I'm going to show you a counterexample in a follow-up video of why -1 to -4 is actually incorrect. But that's your limit. That's how you find it. The radius is positive. It's going through the first circle to the second circle. The radius of this circle, if I drew the whole thing, would be radius 1. The radius of this circle, the next one, if I drew the whole thing, would be radius 4. So those are the partial parts of the circle. The angle would go from theta equals pi. So if I think of the full circle, I rotate around, and right here as it enters is theta equals pi, and it exits out at theta equals 3 pi over 2. So if I set up the integral, I'm going to get pi. I meant to write pi. 2 theta equals 3 pi over 2. And let's fill in the integrand. Integrand, you can either just pop it in there blindly, so you'll have r cosine squared theta plus r sine theta. This part here is x squared plus y squared. And then we have r dr d theta is the dA. This is dA. But if you notice here, you can see if I factored out the r squared, I would get, and by the way, this is parentheses. I did take off a point for parentheses because that's a different meaning. So if you look at this thing here, it's really r squared, because if you factored out the r squared, you would get r squared times cosine squared theta plus sine squared theta, which is equal to 1. If you didn't see that, some of you actually, I think somebody in our class saw that x squared plus y squared was inside the integrand, and that's r squared. So you could immediately see that without transforming. But this part here is just r squared. I didn't take off points if you had this the way it was. So you could have either had r squared r dr d theta, or you could have had this whole gigantic mess there, and that you still got credit. But that's a complete setup. It's a quickie. We can simplify it if it's bothering you. Theta equals 3 pi over 2, r equals 1, and r equals 4, r cubed dr d theta. All right, next I'm going to show you a counterexample to this, that why -1 to -4 is wrong.